Hello, everyone. So, we are going to continue with our tic-tac-toe development. Last time, where we left off was we had just created the save game, just a prototype definition of the function. And it so happens that when I recorded that series of lectures, there was a technical glitch. And there is one particular segment for which I don't have a pre-recorded video. So I'm recording this one. So I don't have about one half of the lectures, which would have been about an hour and a quarter. So I'm recording this one with the intention that we'll continue from where we had left off and go up to the point where we have the continuation of the video. So the benefit of that you're going to get is that I probably will be done much faster than I was before in class with all the interactions and everything. It takes a bit longer, although you do get more information out of it. And there is a challenge for me to do it in a way that it is a perfect stitching of the segments. So let's see how we are going to achieve that. Now, this is what we were looking at last time, and we had decided that we were going to use shared preferences to store our data. So basically, shared preferences, Android. All right. So this is there is a shared preferences class which we are going to use. Now, before we can actually do that, all right, so here, interface for accessing and modifying. So this is actually an interface. The implementation is probably buried in a class of its own. So this is what it gets us. And to get this in reference to this, we just need to call this get shared preferences method. And there is, in fact, there are two ways of doing this. So we have got shared preferences, and we can do it in two ways. One is shared across the entire app, or we can create our own shared preferences objects for different purposes. So the same app can have multiple of these key value stores. And that is what you define using this string and integer. So if we look at the definition of this method, it's in the context class. We will see what it does. Retrieve and hold the contents of the, oh, disappeared on me. Okay. So this is what it does. It gives us a shared preferences object, which is able to retrieve and hold name key value pairs. And here there is a name. This string name is basically a file name. So we could have multiple files like that. And within this same context, there is, if we look, there is a get shared preferences. If we just scroll up a bit, let me search for it. Get preferences. Okay, let's backtrack a bit. I want to go back to the search results and look at this save key value data. And maybe we talked about this in the last lecture a little bit. So what we want to do is we want to do exactly this, save key value data, and this is going to give us a couple of ways of doing it. One is from the context, get shared preferences. So we can identify the database, the file in which it's stored by name, or get preferences if you need to use only one shared preference file for the activity. Okay. So now this is what, since this is what we are going to use, and this is the Kotlin code here. This is for shared preferences, and this is for preferences, if we just want the preferences. Now, to be able to do this, we need access to our activity. And our model does not have access to the activity. So in order to be able to do that, what we will need here is actually shared preferences. We are going to pass it as an argument, shared preferences. And let's call it shared prefs. Okay, this is Kotlin. I'm doing Java here. The type comes later. So basically, now to be able to call this game, since we don't have access, last time where we left off, these save game, the two save game calls were actually there. So instead of calling them from here, is game finished, what we will do is we will call these, and it's showing me an error because I've added this argument here. Don't worry about that. What we'll do is we'll call this save game from the game board, which is basically an activity, you see. So here we have access to the shared preferences. And where do we call it? We will call it from here when the game is over. When do we want to save the game? When it's over. Otherwise, we don't. So that's what we'll do. We'll say game model dot save game. And now we want the preferences object. So this is an activity, so we'll get the get preferences, and it is going to ask us it asks us a mode, what the mode is. And if we look at the documentation, we will see what are the different modes. So right now, see, you see already it gives us here in the code mode private. So if you're curious, go and look at the documentation, see what other modes are and what information they would share or not. Actually, why don't we just do that? Let me open this link in the new tab, shared preferences. And well, it turns out this is the wrong place to look for it. We really need to be looking at context. That's where all the modes are defined. Okay. So here, operating mode, 0 or a combination of private, world readable, world writable, multi-process. So this is what will determine how that information is treated by the operating system. World readable. This constant was deprecated. So really it's there, but it's not suggested that we use it because it allows other apps to read your data. Okay, so what we'll do is we'll just stick to our private, the mode private, context dot mode private. Okay, so what this will do is every time the game board, when it detects that the game is over, it is going to try to save the game. So that will come with the function call here. Now, let's see how actually we are going to save the game. And for that, I'm going to open a file that is actually the class discussion. that took place, and this is the actual photograph of the blackboard that I took after the discussion. And what do we need to save about a game in order to be able to reproduce the game, or in order to display it in the list, right? The list that we are going to actually show. So imagine this here on the left is a game, actual game that was played. And this game X1, and the other information that we want to be saving about this game is the timestamp. That's what we are going to display. And moves played. So basically, which moves were played. And for our purposes, what is the most important is not just the moves played, but the order in which they were played, so that when we recreate the game, we can do some sort of an animation. So that is the information. So when we say moves played, we are actually talking about the order in which the moves were played. And we have already predetermined that the game will always be started by X. So if we know the boxes, the order in which the boxes got filled, then we can reproduce the entire game because they're alternate X and O's. So here we have got these small numbers. You probably, let me just zoom in a bit. This is our square number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So let's say the first move played by X was right in the center, right? So if the first move in the order of moves played would be 5, and let's say the second move played by O was here in this corner, 1. So the next move is 1. And then X played in this 7th square. So we've got 5, 1, 7. Like that. If we have that order, we can reproduce the game. And what else? And this is something that is common to our two courses, iOS and Android. So some of it might be, you may already have seen it. But the way we want to be saving is, since we are using key value pairs, we want for each game these things to be saved: who won, moves, and timestamp. So what we will do is, for game number 1, we will take our key here. It says who won, and we will append the game number to it. Same with the moves and timestamp. So that will become, the key will become who won, followed by the number 1, moves 1, timestamp 1. For game number 2, it will be who won 2, moves 2, timestamp 2, like that. So as many as there are number of games, that many times we will repeat these keys. And of course, to be able to retrieve the data, we need to know how many games are actually saved. So we need to save that as well, number of games. So if 10 games have been played, then we know that we have to iterate over these from 1 to 10. Otherwise, we wouldn't know how many to retrieve. Of course, you could keep on retrieving until you get a nil, but this is another way of doing it. Okay, so let's start first by saving, first by retrieving this number of games and saving it. Okay, so that's our first job. So we will basically retrieve it as an integer. All right, so let's declare a variable number of games played and retrieve this from shared prefs assuming it has been saved before. So shared prefs dot. Now shared preferences allows us to retrieve, you will see as soon as you press the dot, you should see the various functions. So we can retrieve integers, strings, and in the same way, we should be able to, okay, that will come later. Right now we are just retrieving, let's focus on that. So get integer, and the arguments it takes is two arguments. One is the string, which is the key, and this integer is the default value, the second argument. So if it's not in the key value store, then it will just return this, whatever you ask it to return as the default value. So we could say here number of games played like this as a string and say 0, right? So this will do the job. But the danger in doing this is that if when we are saving it, if we make a typo, if we use the wrong case or any difference, then we will not know. Compiler will not be able to tell us that these two are meant to be the same, but they're different. So instead of doing these hard coding of strings in the functions, what we are going to do is this constants object we created for the same reason, right? So what we will do is we'll add more values to it. And whatever we need to save and restore, we will create values for that. So here, following our convention of capitalizing, let's create a value for number of games played, and this same string we can cut and paste it here. So let's cut and paste it here. And then here, instead of using the string, all we need to do is we need to say constants dot, and it will give us the other options. So there it is. This is what we want. This is how we will retrieve the value. And now, because we are saving a game, this was the number of games that have been previously played. So the first thing we will do is we'll increment it by 1. So now when we later on when we save it, it's already incremented. So the way also we go back to the documentation and you see how to make changes to these, saving key value data, writing to shared preferences. Okay. So this is what the Kotlin code is. I've highlighted it here. We've got the shared preference object. We've got that over there as well. And then there is this statement in Kotlin called with. I don't believe we have come across it so far. So let me just tell you a little bit about it. What this with does is with whatever object you want to do something with, you put it in these parentheses, and then in this block, everything that is happening is as if it's happening on this object. And this edit is actually the editor object, which allows us to save information. So once we have got this edit, see there is a note here, you can edit shared preferences in a more secure way by calling the edit method on an encrypted shared preferences object. So that's the other option you have if you wanted to encrypt the data. We are going to not be doing that now. So what we will do is we will use the shared pref.edit, and then we want to put an integer, just like we did a get int, we'll put an integer, and just like before, it's asking for a key and a value. Okay. So let's add this code with shared prefs dot edit, right? So you see here its type is shared preferences dot editor. This is what allows us to save information. And then we will say put integer constants dot number of games played, and then the actual number of games played. This is going to put the information into the key value store. All right. So basically, we have got this much here. We have got number of games played. We incremented it, and we are trying to save it here. Now, additionally, from our discussion, we saw that we will also be wanting to save who won the game and the date and timestamp and the moves played, right? So let's create, what we'll do is we'll create constants for those things. So who won the game? We are going to call it game result. Okay, so we can retrieve it as such. And when you are creating these values, do note that now whatever you put here doesn't matter as long as it's unique, in the sense that you cannot have the same key repeated here, otherwise you will have a conflict. So what now, the only thing that matters is these need to be the same, and they have to be the same. If I have a typo here, let's say I miss an S, it's immediately going to complain to me that, oh, this does not exist. What are you trying to do here? Unresolved reference. That's the advantage of having these constants. And let's say we also do a date time constant so that we can later on save our timestamp. You can even, if you like, you can just call it date time to be consistent, because that's what we are doing. And finally, we want to save the order of moves as we discussed, right? So order of moves is another constant we will create, and we will give it that name as well. Okay. Now then, what's happening is we've got, out of this information, when the game is over, we have certain things available to us. So let me pause here so you can add these. Now, number of games played, that we don't track other than in the key value pair. So we retrieve it, increment it, and save it. But game result for any given game that has been played, we know that game result is known to us. Somebody won the game, we know it. What we can figure out later on, we'll do this, is to the timestamp. But this one, order in which the moves are being played, this is not known to us. And we need to start tracking it. So what we'll do is we'll declare another array called order of moves played. Okay. And just like we declared this array here, we'll use the same syntax, array, but this time maximum number of moves played can be only 9. So let's go with 9. And we'll initialize each of those array elements. This is going to be an array of integers because we are only storing integers. We'll initialize each one as 0, which means when it's 0, that is an invalid move, right? So order of moves played we declare as an array. Array of integers. So one thing I will tell you at this point is, because I'm stitching some code together, you may see some stuff here that is actually not in your project. Don't worry about it. I just deleted a bit of that here. So basically, what we've got now is a setup to create our keys, and the order of moves. Okay, order of moves. We declared the array, but we need to also keep putting in the moves as they are played. And the logical place to do that would be right here in process touch. Before we increment the number of moves played, if we say order of moves played, number of moves played equal to num, that will tell us, the first move is in this array element starts with index 0, this array. So the first move before we increment number of moves played, which is at 0 in the beginning, we store the move that was played. This is our move. This is the square number which was touched, like that. So basically, this now will start getting updated. As we play the moves, we are recording them, the order in which they are being played, so that when the game is finished and we save the game, we will be able to save it. Okay, this pretty much brings us to the point where the next segment of the lecture continues. So I'm going to stop this segment here, and I will ask you to basically let me know if you find that there is any difficulty